go find this page. Put your phones away, please. Or put them up in the calculator thing. Ethan, put your phone away, please. Put your math out. Find me this page. Yeah, Jordan. I see that hand. You're going to go over something simple?
Yeah.
Okay, which one?
19.
You want me to do number 19? Well, I was going to give you the answers to all of them. So let me give you the answers up to 19, and I can do 19 for you, okay? Sounds good? Okay, so there's a few ways you can write these things based on the laws that I haven't given you yet. Number 10, I was working with Riley yesterday, and he ended up with something like 2 to the 0. That is a great way to write it. We haven't looked at the zero exponent law yet, so if this is what you got, that's totally acceptable. Some of you may have written down that this is actually equal to 1. If you take a look here, you're going to get 2 cubed in the numerator over 2 cubed in the denominator, and some of you would have seen that this anything divided by itself is 1. And so some of you may have had 2 to the 0, some of you may have gone straight to 1. Both of those at this stage are totally acceptable. Javon, good morning. How are you? The zombies are coming, Javon. Where are you going to run away to? Think about it. Get back to me. Okay, so that's number 10. Number 11, 5 to the 1. Some of you may have just left it as 5. Number 12 is going to be either. I saw some of you write it as 1 over 8. That's great. Some of you may have written it as 8 to the negative 1. Either one of these is totally acceptable. Number 13, 6 to the 5. Number 14 is similar to 12, 6 to the negative 4, 1 over 6 to the 4. 15 is 2n to the 1, or just 2n. 16 is 6x, or 6x to the 1. 17 is, you could write it 2 different ways. I saw some of you leaving this thing as n to the 0 yesterday. That's great. I saw some of you leave this as 1 yesterday. Also great. 18 you could leave as 2 over 3p, or 2p to the negative 1 up top and 3 in the denominator. At this stage, both are acceptable. I saw some of you do this one yesterday. I saw some of you do that one yesterday. I know, Jordan, you want to see number 19. Okay, let's do it. So, Jordan, we've got a numerator and we've got a denominator. What were you trying to do? No, it doesn't work. Miss S told you it wouldn't work?
Yeah, so I can't use V. I have to use the V.
Okay. You want to do the V's first? We can do the V's first. Okay. So if we want to start, all of these exponent laws require you to have the same base to be able to combine these things. U, V, and 3 are all different bases. So there's nothing we can simplify up top here.
And what does U and V stand for?
Numbers you haven't met yet. Have you ever heard the phrase, everyone is a friend you haven't met yet?
I know. I probably count some letters and numbers.
Yeah, it doesn't work that way, though. We don't know what U and V are. They just represent values we don't know yet. Riley, good morning. We're going over the work from yesterday. Please get it up. So there's nothing we can simplify up top. So let's go look at the bottom. Are there multiples of any letters down there, Jordan? You sure? Let me zoom it in for you more. There are. Okay, what are they? What are the common letters? Those aren't letters. Well, we can deal with the 2 and 3. Let's deal with the 2 and the 3. When you've got numbers.
I thought you were talking about the numbers.
No, I was starting with the letters, but you want to start with the numbers. Let's start with the numbers. Okay, let's start with the letters then. Are there any common letters, Jordan? So what are the common ones? The U's, okay. And they're being multiplied together. So do you remember the rule? No, we're not adding them together. You gotta be careful. When we're multiplying U's, that's what's happening down here. This is all multiplied together. What do we do with the exponents on those letters when we're Yes, when there's nothing written, we make it a 1.
That also goes for the top V.
It also goes for the top V and the bottom V. Let's do them all. Nice. So now we're multiplying the U's. When we multiply bases, what do we do with the exponents?
We add them together.
You betcha. So I've got a U to the 1 and I've got a U squared. So 1 plus...
1 plus 2 equals 4.
Try that one more time.
1 times 1.
No, 1 plus 1. 1 plus 2.
3.
Thank you. Dakota for the assist back there. Okay, so we're going to combine these two. And that's going to give us a U to the 3.
And we're just going to get rid of the V, the other V.
Oh, we're not going to get rid of them. We haven't done anything with the V's yet, so we still have a V to the 1 here. The other thing, you said you want to do the 2's and the 3's. Now we can go back there. So when you've got letters and numbers, yes, it would make 6. We want to actually multiply those together, and it's going to give us 6.
Mine, I got 6, 3, 2 on the bottom row. Also V1.
Well, we're not done yet. We got a little ways to go. And then up in the numerator, nothing's happened yet. So I'm just going to change the order. Actually, you know what? We don't even need to change the order. I've got a V to the 1 times 3U squared. Good morning, Garrett. So now we can keep going, Jordan. I have nothing common in the numerator. I've got nothing common in the denominator. So now we're going to work top to bottom. Which would you like to work with first, Jordan? No, but what letter in the top would you like to work? Because we're going top to bottom now. We have to work across. With the V1 and the V1, okay. When I divide these bases,
You get V1.
I don't get V1. When I divide bases, what do you do with the exponents? I subtract them. Okay, cool. So what's 1 minus 1?
0.
So this is going to be V to the 0. And when you do the subtraction, whatever's left goes up top. So 1 minus 1 is 0. Okay, so those are V to the 0. Let's do and that's done, and that's done. And now we do the U's. What am I going to get when I do the U's, Jordan? I got U squared over U cubed.
The U stay the same.
What do you mean?
Stay the same.
Well, because they're both U's, we can simplify them. Yeah, they're the same base.
So U plus U equals U.
No, we're not adding them. When you have them written like this in a fraction, that means we're dividing. So we've got U squared.
Divided by U.
Well, it's U to the power of 2 divided by U to the power of 3.
1.
So it's going to be, so Jordan, it's always the top, when we divide, Jordan, it's the top exponent minus the bottom exponent. So if you look here, what is 2 minus 3? Try that one more time. I'm at 2, it's minus 1, thank you. I see that enthusiastic hand back there. I am not ignoring you. And on my last step, Jordan, the U's are done, the V's are done.
No. Divided by 3.
Other way around. The 6 is on the bottom, so it's 3 divided by 6. No, it's the 6 is on the bottom, so it's top divided by bottom. 3 divided by 6.
2.
Almost.
1. Can't divide 3.
Jordan, you were the one that did this yesterday in the example that I did. If I had this, Jordan, if I had 3 over 6, what would I do with this? What did we do with it last chapter?
I don't know. You mean simplify?
Yes, you do have an idea. You do know. So what do I do? How do I simplify 3 over 6?
Yeah. Hold on.
It's in there. Dakota, I saw that enthusiastic hand. You want to help him out now? So, Jordan, 3 and 6. Jordan.
1 and 2.
Yes, it's going to be 1 over 2. So we can do the same thing here. If I've got a 3 on top and a 6 down below, I'm going to divide these both by 3. And I'm going to get 1 up top, and my 2 is going to be in the denominator. And at this stage, if you wrote this, you'd be good. So it's, I mean, there are some steps to take, certainly. But you can take all of the steps. You just have to recognize what steps to take. Jordan, does that help at all? A little bit? Nice. Kind of? Okay. Okay, number 21. You can either write it, I saw some of you leave it yesterday as 3 over uv. Some of you left it as 3u to the negative 1, v to the negative 1. Either one of these is totally acceptable. I'll zoom this out. 20 is the one that Liam asked me to do as an example yesterday. And then 22, it looks pretty awful, but it's really not. It's totally doable. You're going to get 1 over 12 x to the 5y, or I saw some of you leave this as x to the negative 5, y to the negative 1 all over 12. I saw someone leave this as y to the negative 1 over 12x to the 5. Any one of these 3 expressions at this stage is totally acceptable. Any one of those 3 are okay. Let's go back and redo my attendance real quick. Or should I just move on with this stuff? Okay, let's keep going then. We got 4 exponent laws. We'll rip through them today. You guys will see the patterns. And then you will be free to play with some of this stuff. Okay, here we go. Well, just like last chapter, I think this chapter might be beneficial to collect some stuff on the board. This is a place to reference all of these things. So the first one we had, well, how do I want to write this? If I had something like 2 cubed times 2 to the 4th. When we multiply, we add the exponents. 3 plus 4 is 7. And then we divide it. 2 to the 5 over 2 cubed is going to give us 2 to the 5 minus 3. It's top minus bottom. I'll just write down an example for each. Save a lot of words. Okay, let's take a look at these. Okay, rule 1, we multiplied bases. Rule 2, we divided bases. Rule 3, we're going to take those same bases and we're going to put them to a power. So what does it mean to square something? Yes, Dakota. We want to, multiply it by itself 2 times. So what we're going to do is we're going to take what's in the brackets here, and we're going to multiply it by itself twice. So if I have 2 cubed squared, and I want to write that thing in expanded form, what that's going to look like is 2 cubed times 2 cubed. Sorry? 2 cubed. C-U-B-E-D. Not C-U-T-E. It is too cute. Numbers are cute. That helps you remember it. Sure. 2 cubed, or 2 to the power of 3. Now, this looks an awful lot like an exponent law we had yesterday. When we multiplied bases yesterday, what did we do? When we multiplied the same base yesterday, what did we do with the exponents? We added them. So, if we're going to apply that law, that we learned yesterday. I'm going to add these two together, and I'm going to get that this thing's going to be 2 to the 6. Now, if you take a look at where we started with this, 2 to the 3 squared, and we ended with 2 to the 6 after we applied that first exponent law we looked at yesterday. How can I use 2 and 3 to just jump straight to the end here? How can I use 2 and 3 to get 6? Garrett.
Times 3 twice to get to 6.
Times 3 by 2 or times 3 by 3?
Times 3 by 2.
Times 3 by 2. Sweet. So what I could do is I could take a look at these exponents and I could have multiplied them together. That's interesting. Let's see if the pattern continues. I've got 5 squared cubed. What does it mean to cube something? Yes, Garrett.
You times it 3 times. Or more.
By what?
Itself.
Multiply by itself 3 times. Good. So if I have 5 squared in brackets and I'm cubing it, that thing in the brackets is the base. So we're going to have 5 squared times 5 squared times 5 squared. When I multiply same bases, the rule from yesterday was to add up the exponents. So this is going to give me what?
6.
5 to the 6. You betcha. How could I have used 2 and 3 to get to straight to 6?
2 times 3.
You betcha. I could have started these exponents and multiplied them together. Well, we've used 2 and 3 a bunch. Anyone want to take a guess at what's going to happen here? Sorry? I thought I heard something. Okay, let's do another example with letters. Squaring something means multiplying it by itself. So x to the 4 squared is going to be x to the 4 times x to the 4. What am I going to get if I apply the rule we learned yesterday? Yeah, Dakota. We're going to add them. 4 plus 4 is 8. How could I have gone straight from the beginning to the end? What could I have done with 4 and 2?
Times 4 by 2.
At this point, I think the pattern is making itself pretty straightforward. Thank you, Garrett. Thank you, Harsh. When we have a power, so something to an exponent in brackets, to another exponent, these two things are going to get multiplied together. So what's this last one going to be? We're going to skip the middle stage and we're just going to come straight to the end. If I have y to the 5 to the 7, it's going to be y to the 35, you bet. So here's the rule. When you have a power of a power, we're going to multiply. Actually, that might not be a great color. We're going to multiply the outer exponent with the inner. So I'll do one example. Let's flip a couple pages ahead. And let's take a look at number 1. No, not number 1. Ooh, let's flip 2 pages ahead. Take a look at this guy here, number 18. Oh, I lied again. We're going to go to 21. Find me that guy there. Let's do an example of this law. I've got something inside a set of brackets. There's a power on this one, and there's a power outside. So the exponent law we just looked at says when I've got a power to a power, I'm going to multiply the exponents together. But I've got two things inside that bracket, so does anyone want to take a guess at how this is going to go? Mr. Keeley's looking frustrated this morning. Or should I just tell you? Sahil, do you have any thoughts? No thoughts?
Is it you multiply the thing so you get 9?
Yeah.
9 overall.
Oh, careful. We're going to have u to the 9. So I multiply these two exponents together. But I've also got a 6 in there. So what do you think is going to happen to that 6? Where are you getting the 9 from? Oh, I see what you're suggesting. Not quite, Harsh. You're close. When I've got, morning, man. This part is good. We have a power to a power. We're going to multiply these two things together. This next piece, though, is actually where the next rule is going to take us. If I have something else multiplied inside that bracket, this outer exponent got applied there. If I'm cubing this whole thing, what's that going to give me? It means I'm multiplying 6u cubed by itself 3 times. I'm going to get 6u cubed times 6u cubed times 6u cubed. The u cubeds are done. That's how I got the u to the 9. What's going to happen at the 6? Yes. Mm-hmm. Times 6 again. Times 6 again. Or, instead of writing it as 36 times 6, I mean, that's the whole purpose of these exponent laws. If I have 3 6's multiplied together, how could I write that using exponents? 6 times 6 times 6 is 6 to the power of 3. So these two 3's are going to multiply together, and that 3 is actually going to multiply with the exponent there on the 6. Okay, flip back. This is the next law we're going to look at. Yeah, really.
When you go up and down.
I know. I got to keep you awake. I need to know who's asleep. Jared, flip back. See, this is how I kept Jared. Jared's sleeping in the front row. Keep going. Flip again, Jared. No, back. Back to page 6. No, Jared, you're good. I said, Jared, you didn't write anything down. Again. Classic Jared. Okay. So, power to a power, we multiply them. Now when I've got multiple things in there, this is an example of what we just did. When I square something, and that something is multiplied with something else in a set of brackets, I've got 2 times y cubed. If I write it as expanded form, I'm going to get 2y cubed times 2y cubed. My y's are going to combine using the exponent law we looked at yesterday. I get y to the, what do I do with these exponents? Well, here I multiply. You bet. 2 times 3 is 6. Here, when I write it out in expanded form, I would have added them, but 3 plus 3 would have also gotten me 6. 2 times 3 is 6. 3 plus 3 is 6. But now I've got 2 2's multiplied together here too. So I could write this thing as 2 squared. And if you look at what has to have happened for that to be true, this outer 2 needs to get applied, that exponent needs to get applied to both pieces inside the brackets. So all of these are going to play out that way. On all 3 of these, the outer exponent needs to get applied to what's going on the inside. I've got two things multiplied together here, so that outer exponent's going to get applied to both of these pieces. And we're going to use this rule that we did up here. When I've got a power to a power, I'm going to multiply them together, and now I need to do it onto each piece. So the x's are going to become x to the 2 times 2 is, y to the 3 times 2 is, you bet. Thank you, Harsh. Harsh, you want to try this guy? Okay. What am I going to do? Do any piece of it, okay? Maybe forget the negative 2's there. Sorry? I can't hear you, man. You got to speak up. I can't hear you. Yes, do that. Yes. So this piece is going to give us x to the 6, absolutely. And this new exponent law that we're adding here says that we take the outer exponent and we apply it to everything that's going on inside. So we can leave this thing as negative 2 cubed. The last one's going to be the same. I've got 3 things multiplied together inside these brackets. That outer exponent's going to get applied to each piece on the inside. So it's going to go into all 3, the 4, the x cubed, and the y to the 7. It multiplies with any existing exponents. And so we're going to get 4 squared x to the, what's going to happen with the x? It's going to be 6, Denny, thank you. And the y is going to be to the power of 14. Thank you, Garrett. So the exponent rule here is that you have to apply the outer exponent onto each inner, I'll say inner piece. Everything that's being multiplied together needs to have that exponent applied to it. Okay, that's 2. We've got 2 more. Hang with me here. This rule we actually did kind of look at on the first day. We looked on the very first day, we talked about what it was like to put fractions to exponents. And without really talking about it, we did this. What is 2/3 squared? What does that mean to square something? Are you guys sharing one pencil? Taking advantage of the new kid? Where's your writing utensil, Harsh? You don't know? Harsh, would you like a pen or a pencil? Are you going to treasure this forever, keeping it for always, remembering me? There you go. Oh, so close. Okay. Keep it, Harsh. Okay, what does it mean to multiply? What does it mean to square something? Garrett, what does it mean to square something?
To multiply itself by 2.
So close.
By itself.
Yeah, twice.
That's the way I think of it.
Yes, I can appreciate that. I just want to make sure that way that you're saying it the way you mean it. Or sorry, that you mean it the way it's supposed to be. I'll say it that way. Okay, so I have 2/3 times 2/3. Using exponent laws, yeah, I know all of you guys want to say, well, that's just 4/9. But I want to use exponent laws to demonstrate what's happening here. Yes, Jordan.
I'm gonna go time, then you say exponential laws. I'm like,
It's close, though. It's similar. It's related.
related.
Yeah, I'm going to write 2 times 2 is 2 squared. No, see, and I said that's exactly what you guys want to do. But I'm trying to teach you how to use these exponent laws, so we're not going to turn this thing into 4/9. 2 times 2 means I could write this thing as 2 squared. I have two 2's multiplied together. In the bottom, I've got 2 3's multiplied together. So I could write that thing as 3 squared, and now I want to show you what's happening here. I don't want to write that as 4/9. What I want to do is demonstrate that when you have a fraction and an exponent on the outside, that exponent has to move into the numerator and it has to move on to what's in the denominator. That outer 2, it's going to become 2 squared, and the denominator is going to become 3 squared. See you later, Alex. So when I've got a power of a quotient is a division statement, or a power of a fraction, you think of it that way too. The exponent on the outside has to apply to everything in the numerator and everything in the denominator. So this question here is going to be similar. I've got 2/3 cubed. This 2 is going to move into the numerator. It's going to move into the denominator. And I have to use the rule that we had before. When there's already a power there, we're going to multiply these guys together. So this thing's going to become, I'm going to go straight to the end here. If I apply that outer exponent to the numerator, I'm going to get 2 squared. If I apply that outer exponent to the denominator, what am I going to get? I have 3 cubed squared in the denominator.
Well, multiplying, right?
You betcha.
How many is 9?
3 times 2?
I mean, 6.
Good. Love it. So this thing is going to be 2 squared over 3 to the 6. We applied the 2 to the numerator and the denominator. We multiplied those two, the exponents that are there, together. Sweet. Life gets weird when we have minus signs. So I'm just going to tell you this. When you've got a minus sign like this, I want you to treat it as a -1. And we did take a look at this on the first day of the chapter. So how we're going to write this is we're going to write it as -1. Let's spread it differently. I want to put that -1 in the numerator. That's the other thing I told you to do with negatives on fractions, is to pull it up into the numerator. This is what I've got here. And there's a minus sign sitting there. It's the same as having -1 in the numerator, x squared over y cubed. And now I'm going to apply the exponent laws that we've looked at, both of the previous two. All that means is I'm going to apply the exponent onto each piece in the numerator and into the denominator. So the -1 is going to become -1 cubed. The x is going to become x to the power of what? Power to a power means 6, thank you. And the denominator is going to become y to the? You betcha, thank you, Garrett. Then the only other thing we've got to deal with here is this. -1 cubed is -1 times -1 times -1. So what's that going to be? -1 times -1 is? Careful, that's -1 plus -1. What's -1 times -1, Jordan? Thank you, Garrett. It's +1. Because a negative times a negative, Jordan, is a positive. And then I'm going to multiply by a -1 again. which makes it -1 again, Jordan. Thank you, good. So this is going to become -1 x to the 6 over y to the 9. This is a very similar question. How is this one going to change compared to this one? Someone be brave. This question looks exactly the same as this one. How do we do it?
Make negative sign -1
Yep.
times 4 to -1 x to 4 y.
Okay, you wanted me to put the 4 on the -1? Is that what you said?
Yeah.
Okay. So I got the -1, I've got an x2 over y3, and that whole thing is to the power of 4. Good, that is the correct first step. That's what I understood you to say. Is that right? Is that what you mean? Okay, so Garrett, next step. Keep going.
And then you times you times the 2 with the 4, the 3 with the 4, and the -1 with the 4.
Yes. So I'm going to have the -1 to the power of 4, x to the power of, I'm going to multiply the 2 and the 4 and get 8. And y in the bottom is going to be to the power of 3 times 4 is 12. Fantastic, Garrett. One more step. Yeah, I know. I'll give you time. Yeah, go for it. What's going to happen with this one? Or if anyone wants to take over from Garrett. Garrett's been doing great. What's the last step here? I'll zoom it in perhaps so it's easier to see.
-1 times -1 times -1, you get 1. And another -1, so 1, x.
And everything else stays the same. Love it. Good job, Garrett. The difference, the reason that I put both these questions in here is because this one has a -1 to an odd exponent, which makes the question negative. This one has the -1 to an even exponent, which makes the thing positive. Good job. So the power of a quotient rule is going to be similar to the power of a product rule. We want to apply the outer exponent onto everything. Am I still on the screen? I am not on the screen. Everything in the numerator and denominator. And there's one more. But this last one is easy. We like easy, right? And I assure you it is easy.
I don't believe you.
We're going to flip the page. I'm going to show you how easy this is. The zero power rule. Now, the hard part for this one is me explaining how it works. The easy part is once you know how it works, it's one step and it's done. Oh, sorry, my apologies, Garrett. You bet. Oh, what happened? Oh, we're good. Okay. If you're ready for the next page, hang on the next page. Jordan. What am I going to ask you to do, man? Put the doodles away and flip the page. Yeah, but put the doodles away. We're almost done, and then you can doodle. Hey, Garrett, you let me know when I can flip. Okay, thank you, sir. Here we go. Okay, so this table here, I'll explain the rule. The explanation takes some time, but the rule itself is really actually easy. It's not the thing the math teachers say where it's easy and takes forever to do. When I say easy, I literally mean it'll take you a fraction of a second to do. It'll be great. So let's take a look at what's happening here. This is a table of powers of 3. I've got 3 to the 5, which means I'm going to multiply 3 together 5 times, and I'll tell you that that is equal to 243. 3 to the 4 is 4 threes. 3 times 3 times 3 times 3 is 81, and so on. Now, here's my question for you. How can I go from 243 to 81? What mathematical operation is going to let me go from 243 down to 81? Louder, Jordan? Oh, I thought you said something else. That's what you said the first time was divide, yes. We're dividing by 3. Okay, 243 divided by 3 is 81.
That's what I was thinking too, but I said minus.
They are similar in some respects. So 243 divided by 3 is 81. Same then applies to this guy here. If I divide this row by 3, I have 5 3's multiplied together, and if I divide that thing by 3, one of these 3's is going to cancel, leaving me with 4 of them multiplied together, which means the same thing is true over here. If I divide this thing by 3, it's going to drop the exponent from 5 down to 4. So each one of these steps dividing by 3 is going to change it to 3 to the 4, 4 3's multiplied together, and 81. Let's do it again. 81 divided by 3 is 27. But dividing this guy by 3 will also knock one of these 3's off here and mean I have 3 3's multiplied together. The same is true in this last column here. If I divide this thing by 3, it's going to knock this exponent down 1. Let's go over here. 27 divided by 3 is 9. 9 is 2 3's multiplied together. And if I divide 3 cubed, or 3 to the 3, if I divide that by another 3, I'm going to get 3 squared. Let's do it again. 9 divided by 3 is 3. 3 times 3 divided by 3 is just a single 3. And if I have 3 squared, I'm going to divide that thing by 3. I'm going to get 3 to the 1. Now this last step is where this rule comes in here. What's 3 divided by 3?
1.
It's 1. So then 3 divided by 3 is 1. What happened over here? In this first column, when we divided by the base, it knocked the exponent down 1 each time. So if I take 3 to the 1 and I divide it by 3, what should go right here?
1 to the power of 3.
Take a look what happened here.
3 to the power of 0.
There you go, Jordan. 3 to the power of 0.
I was thinking 1 and 0, but that's not going to work. It's going to be going 3 to the power of 5, 3 to the power of 4, yada yada until it gets to 0.
Exactly.
It can't go past 0.
Actually, it can.
What?
What happens if we divide it again?
It goes to -1.
What's 1 divide? It's going to go to -1. Love it.
It's going to go to the -1.
It's going to hit all the minuses, you bet. 1 divided by 3 is 1/3. And so this is where we're going to start to get, there's a rule here that I wasn't going to tell you, but then Jordan decided to ask about it. There's a rule for negative exponents, which we're not going to do because it's not part of the grade 9 curriculum.
But we're doing it anyway.
Nope. I am going to tell you it exists. If you would like me to show it to you, call me over. I will do it with you specifically. I am not going to do it for the entire class because 4 more laws is enough. So says whoever decided Math 9 curriculum. So this we were going to leave for grade 10. This is the only thing that gets added in grade 10 is the rule for negative exponents. What I'm trying to show you right here, Jordan, is this line right here. Anything to the power of 0 is 1. It doesn't matter that I was using 3's here. I could have used 2's. I could have used 5's. I could have used the letter X. Anything to the power of 0 is 1. And it does not have an expanded form. So 2 to the power of 0 is 1. 2 times x times y to the power of 0, that whole thing's inside a set of brackets. If you've got a 0 on the, yes, Jordan, it's 1. It doesn't matter how much stuff is going on inside there. If there's a 0 outside, it's 1. So 2/3 to the power of 0 is? The only little snag is when I do something like this. If I've got x to the 0 plus y to the 0, it's not 0. X to the power of 0 is? Anything to the power of 0 is? 1. So x to the 0 is going to be? 1. Y to the power of 0 is? 1. And I'm adding those two things together. So this one's actually 2. Yes, thank you, Harsh. This is going to lead us to BEDMAS, which is what we're going to do in a couple days. I know we love, this is the 5th time we'll have seen BEDMAS. Some of you are getting tired of it. Anything to the 0 is 1. I'm done. Thank you for hanging in there with me. Oh, sorry, Garrett. Well, Harsh is done, so I figured maybe you were done too. Or maybe Harsh didn't write it down, we'll never know. Okay, see, Harsh is done. See, it's always, Garrett, the other trick is, for me, it's hard to tell if you're done writing because I'm pretty sure Jordan's done writing and he's just drawing pictures. So it's hard for me to know if now is a good or bad time to flip. Okay, this page here is a summary of all of the rules. I will let you use this page on any quiz I give you for this chapter. I will let you use this page. Now, I'll let you use it on any quiz. I'll commit to that for now. All the rules are here. This is what I'd like you to try. We're going to start here. I want you to start with the odds. We have no on God this morning, so it's just be me and Miss S. I'd like you to try to apply these exponent rules to these questions. On your mark, get set, go. Once you've done the odd, if you've finished the odds, let me know. I have an answer key we can use to check. It's time to start walking around helping one-on-one. On your mark, get set, giver.